essentially they were given the active agent or the standard of care, the placebo, or the preventive agent. So blinding means that you don't know which arm you've been assigned to. Why do you randomize? I talked about this. We randomize to give us balanced groups of people. We take out of the equation the people themselves can't determine whether they're going to get spam or not get spam. The coin flip determines. The coin flip will give you two groups that are very much comparable. So randomization decreases the risk of a selection bias and increases the risk of comparability. That's why we randomize. I'll show you that in an example in a minute. We mentioned blinding. A placebo is a pill that looks just like an active agent pill. For example, I might want to know whether aspirin prevents heart attacks from occurring. And I'll ask people to take a white pill every day. Some people get a white pill that contains aspirin. Some people get a white pill that doesn't contain aspirin. It would be essentially a pill that looks like aspirin, tastes like aspirin, but doesn't contain the active ingredients of aspirin. Placebo means that you're given a pill that has no expected beneficial result. That helps you to enhance blinding. All you know is you're taking a white pill. You don't know whether the white pill is aspirin or placebo. The advantage of blinding people, as I mentioned before, is to take that knowledge of what treatment group they're given out of the equation. So when you ask them how you feel, the fact that they know they were taking aspirin or know they were taking placebo cannot influence their answers. The fact that they know they're taking aspirin, know they're taking placebo, cannot influence their decision to comply with the treatment assignment. There's something called a placebo effect. It goes back and sometimes referred to as a Hawthorne effect. It goes back to a study done many, many years ago, more than 50 years ago, in a power plant in Illinois, outside of Chicago, in the town of Cicero, which I think is well known for the town where the mobster Al Capone was based. But Cicero had a power plant called the Hawthorne Power Plant. And there were a number of studies done in that power plant where they tried to improve worker efficiency. For example, they wanted to know if they make the lights brighter, will people work harder? Will they become more efficient? And what they tried were a number of changes in the work environment to see if they could improve the output of the workers, to improve the efficiency of the workers. And they noticed that doing certain things, like making the light bulbs brighter, improved working efficiency. But they also noticed that if they did nothing but just take the old light bulbs out and put them back in, so that people were under the illusion that they were being observed with something changing, somebody had changed their light bulbs, that people started working differently. So just the fact of being in a study might influence the outcomes you observe, because psychologically it might affect the way people think. They think they're in a study, they think they're getting some sort of agent, they know somebody's monitoring their outcome. That might influence how they live their lives. That might influence indirectly the outcomes you measure. So what you want to do is take out of the equation this Hawthorne effect. You want everybody to get the illusion that something's happening to them. Everybody to get the illusion they're taking a pill. Everyone getting the illusion that someone is following them. And therefore, that illusion is in both of the groups you're comparing. So one group is getting aspirin plus illusion. The other group is getting illusion itself. And now you have a fairer study to see if aspirin has a benefit. So if you just gave aspirin to one group and gave the other group nothing, then two things are happening to the aspirin group. They're getting aspirin and they're also getting a pill. They know they're getting a pill. They know they're part of a study. They know they're being monitored. And that itself might influence the way they live, and that itself might influence the outcome. While the comparison group that's getting nothing has neither of those two benefits. So if you find out that the aspirin group had better outcomes at the end of the day compared to a group that had nothing, you don't know whether the benefit was due to aspirin or the benefit was due to the knowledge of being in a study. And that's why we give placebos to people. Okay. What else do we do? We then follow people just like in a cohort study. We measure the outcomes. We also measure adverse effects. We measure compliance. And then we have to look at the data. Once these outcomes start occurring, because of the ethics of an experimental study, because of the need to be in equipoise, we cannot keep a study going Once we're convinced that one arm is better than another, we have another board, another committee known as the Data Safety Monitoring Board, where the statistician and some outsiders meet, say, every 6 months, look at the results in hand as of that time, and make a decision. Do we stop the study now, or should we keep on going? And there are many reasons for stopping a study early. Maybe we look and say there's an apparent effect. One arm is doing remarkably better. Now we're no longer in equipoise. It's no longer ethical to withhold the better treatment from the arm that's not getting that treatment. Maybe we're seeing no effect, and therefore it might be unethical from a financial point of view to keep on going. Why should we keep this study going for another 5 years if it has no hint of showing one arm being any better from another? Or maybe, more importantly, one arm is having worse side effects. Maybe the aspirin users haven't shown a benefit yet from taking aspirins, but they're showing a lot of harm. They're having a lot of stomach problems, they're having a lot of bleeding problems. Ethically, we no longer are in equipoise, we have to stop. So there are other reasons you might end the study. You don't have enough people, it's hard to enroll people, the data is just poor quality. Maybe some group in Europe just published a result 1 year after your study started, showing that aspirin prevents heart attacks. You can't keep the study going because now you're no longer in equipoise because of that new information published from a new group. Or maybe no one's taking their pills. Again, there's no reason to keep the study going. There are many reasons for stopping a study early. The main reasons, though, are ethics. We then verify the outcomes. Usually there's a committee to verify that people who say they got heart attacks really did get heart attacks by checking their medical records. We then do an analysis. First analysis we do is we compare everybody who is randomized to one group versus everybody randomized to another group, regardless of whether they complied with their randomization or not. That's what we call an intention to treat analysis. That's the most valid analysis you can do, because that's the analysis that is linked to the comparable groups that you started with. As a secondary analysis, you might only want to compare the people who complied with their treatment assignments. That's what we call an on-treatment analysis. Or you might want to do analyses within certain subgroups of people, say just among one racial ethnic group, like Native Hawaiians, to see if one intervention is better than another. And then, so here's an example to close off the experimental study. This was a study Marjorie was involved in, a multi-center study, looking at trying to prevent diabetes. It was the Diabetes Prevention Program Research Group. I gave you the paper to read for last week. It was a randomized trial of 3 different agents: lifestyle modification versus chemical treatment with this drug metformin versus placebo. They enrolled 3,234 non-diabetics who were at high risk for developing diabetes based on having elevated fasting and post-low glucose concentration testing. Their outcome was the development of diabetes. Well, let's see what they show. This is their table 1. Here are your 3 groups: 1,082 people getting a placebo, 1,073 getting metformin, 1,079 getting lifestyle intervention. Roughly the same numbers of people in each group. It's like flipping a 3-sided coin, each with a third chance of coming up heads. So 1/3 of your people get placebo, 1/3 of your people get metformin, 1/3 just get a lifestyle with no drugs whatsoever. Notice, for example, the percentage of men: 31% in one group, 33% in the other group, 32% in the other group. Very, very balanced. Look at the percentage, say, of whites: 54 in one group, 56 in another group, 54 in another group. Average age: 50 in one group, 50 in another group, 50 in another group. This is what you expect from randomization in large studies. You expect to have groups, in this case 3 groups, which are very balanced in terms of their risk factors. In terms of what Marjorie's group was able to show, these are the results. After a follow-up of 2.5, almost 3 years, incidence of diabetes was 11 cases for every 100 person years in the placebo group, 7.8 in the metformin group, 4.8 in the lifestyle group. So lifestyle group had more than a 50% decrease in the incidence of developing diabetes. We looked at these results, these are her 4-year cumulative incidence of developing diabetes.